Alright, so welcome to the next video. Here's another example of the rotation of the rigid body. This is actually very nice. You have a system of two particles. These particles are actually illustrated here as a 300 kilograms ball and a 600 kilogram ball. They are connecting by a massless rigid rod, which doesn't quite exist as a massless, but for the purpose of the problem, I guess we'll take it as an example. Has a certain length, it's 40 centimeters, and the structure rotates about the center of mass with an angular angular velocity of 100 RPM. So the question is, what is the total kinetical energy of this system of rotation, right? Good. So in order to find out what that is, this system rotates. That means it's going to rotate around the center of mass. So this is a good illustration. So common sense kind of tells you that the center of mass has to be somewhere between the two particles on the massless rod, but it will be further out from the lower mass and closer to the higher mass. So we need to find that first. So as you recall, center of mass, yes, it's the sum of all the masses times all the distances, right? Divided by the sum of all the masses. So let's see what we have here. Now, depends how you actually put that. How do you calculate the center of mass? Remember what I said? Try to put your system that has the zero at one place, that one distance will cancel out. So let's say our 300 gram mass is situated at 0 centimeters, right? So we're going to stick to that, plus our 600 gram mass. It will be 40 centimeters away, because we don't know what it is, right? We are just making that assumption, divided by the sum of the masses. Okay. I didn't have to convert any units, right? Because the grams will go away. The result here will be in centimeters. So if you are doing these terms here become 0. Now use your calculator, simplify out your 100s. Okay, I'm getting 2667 roughly there. And this will be centimeters. Now that we know the center of mass, we can calculate the moment of inertia. Okay. Now, this moment of inertia has to do with how many particles are present, right? So in general, if you remember, moment of inertia is the contribution of each particle, so the mass of each one, times r squared, where the r is the distance from each particle to the center of rotation. So I'm going to call this center of rotation, which is also the center of mass. So in our case here, let's see what this becomes. This becomes our 300 grams, I guess I can convert later, times x center of mass squared, plus our 600 grams. Now, where is that situated? So if you look from the center of the 600 to where the center of mass is, this distance right here will be nothing else but 40 minus x center of mass. So let's put it down here, 40 centimeters minus x center of mass, and this is all squared. Very good. Let's plug in our numbers, or actually even convert now. So 0.300, this will be kilograms. This one right here becomes 0.2667 in meters. So we're going to put that number in now. And this will be all squared plus 0.600 kilograms. And then you have 0.4 minus 0.2667, that becomes 0.1333. This would be meters all squared. All right, so that becomes, so you get I equals, well, I got 0.032. You can check my work with using your own calculators, kilograms meters squared. All right, so we got the moment of inertia after we found out what the center of mass was. Finally, if you remember, the kinetic energy or the kinetic rotational energy, it is 1/2 I omega squared. Very well. So I think we have to convert this 100 RPM. So we're going to multiply with 2 pi and divide by 60 while we plug in our numbers. So 1/2, 0.032. And then omega becomes 100 times our 2 pi divided by 60. Remember, this is energy, so this is all square, by the way. Energy measures in joules. You can actually break down each one of them and see how valid that is. And this becomes, so don't forget to raise this to the second power. Let me double check my work here because the first time I don't think I put that in. Okay, so I get 1.75 joules. So this is the total rotational kinetic energy. All right, see you in the next video.